Giving our designs visibility to the world around them is becoming more important in a wide array of applications. Image sensors continue to improve in price and capability, but illuminating the source we're trying to view can often be a challenge, as not every application is made to stay out of the dark. For those situations where light levels may be lower than we'd like for ease of our designs, how can we utilize light wavelengths like infrared that are invisible to the human eye but perfect for our electronics vision? So we've talked a lot on the current about machine vision and artificial intelligence, how that's changing so much of electrical design today and offering a tremendous amount of new features to our products. And that's an amazing thing, but there are often applications where light pollution or light noise are not something that we want to see. Maybe we're illuminating our front yard, our backyard, we're illuminating a parking lot outside of an apartment complex. We don't want visible light to be out there. And so when we have that type of an application, what do we do to really turn to other light sources like infrared LEDs in order to allow our machine vision to see that area and do the work that we expect from them? Today I have the privilege of speaking with Russell Willner, who's the Senior Marketing Manager for Visualization and Sensing Products at AMS OSRAM, is an expert in infrared technology. Russell, thanks so much for joining me on The Current today and sharing your expertise.
Well, thanks for having me, Todd. I appreciate the
I'm really looking forward to this conversation because, again, I think this is such an interesting area of technology. And when we talk about machine vision on The Current, we typically have talked about applications where we've got enough light to see the world around us. But there are so many times, like in security applications, like I just mentioned, where we don't want to have that light pollution. And so I think that tends to be where my mind goes. As I think of security applications, security cameras, things like that, where we might be using IR LEDs. What are maybe some of the applications that you've seen that are maybe a little bit more unique where infrared technology has come into play?
Well, they come in a lot of different areas. I mean, if you're looking at robotics, you may not need full, color fidelity, and so having just a, monochrome image would be adequate. Let's say you have a robot working in a storage facility. It doesn't have lights on because there's no people there, but you may want to have the robot picking and placing, merchandise on different shelves, etc. It doesn't need to have, the white lights, the bright lights that we're accustomed to in order to get the job done. So they may just use a infrared LED to illuminate where they are. And
Right.
and so only when there's a human will they turn on the house lights, etc.
Right, right. And I assume with that, if you're going to a monochrome and you're not going with full color, that way you can kind of use a different camera sensor as well that maybe is lower cost. And also, I assume it would reduce the processing power required for that particular application. Would that be a fair statement?
Not necessarily, because
Okay.
the thing
Okay.
is that if you look at where the volume is on the sensors, it's, the manufacturers are really looking at, where the biggest markets are. And especially if you have periodic need for, the color fidelity, as it were.
Right.
So those imagers, they don't, cut off immediately when it's you get to the IR. You're still going to get some sensitivity in the IR range.
Okay.
Maybe not as
Okay.
great, but you'll still get that.
It's still there. It's still there. Okay. Thanks for clarifying that. That really is very helpful. So let's talk a little bit about exactly how it works. Because again, when we think of a camera, we're thinking about the visible light. We're thinking about what we can see and assuming that if we can't see it, our camera probably can't see it as well, which we know IR technology completely changes. So how does IR technology really marry with the camera to make vision possible?
So, I mean, if you look at the sensitivity of the camera, and each camera manufacturer is got different sensitivity, but what we look at is what is the quantum efficiency of the pixels, in the infrared region. And so if you look at, let's say, green, where the camera would be quite sensitive, that's where our eye is most
Right.
sensitive, and say that that's 100% sensitivity. When you go out towards, say, 800 nanometers, which is in the near infrared, you're
Right.
probably in the 60% sensitivity range. As you get to 850 nanometers, you're
Right.
now going to drop to maybe 35% sensitivity. And as you get to, say, 940 nanometers, you're going to be maybe at 20% sensitivity. So, in
Right.
order to get the same brightness level, you're going to need to give more light energy at those
Right.
given wavelengths. The reason I say those different wavelengths is because the trade-off that you have is there's this thing called red glow, because the nearest wavelength to infrared is red. And
Right.
so as you know, you're not going to cut off, immediately. If you say I have an 850 nanometer IR LED, you're not only giving one wavelength, you're giving a distribution of wavelengths. And so
Right.
even, you know, even at low levels, even at 1%, in dark environments, the red portion is going to be visible. And so
Right.
is that an issue? Some people like to have red glows, other people don't like to have red glow. Some people like to have, you know, uh, their cameras noticed, so
Right.
that it deters people from doing the wrong thing.
Right.
Other people want to keep it as stealth as possible, and not let passersby know that they're being watched.
Right. Right. Well, and I think you probably with that answer have already hit a little bit on my next question. But obviously, like you mentioned in the wavelengths, our eyes can see between about 400 nanometers to about 700 nanometers or so,
Right.
and then the infrared is between about 800 to 1,000 nanometers. I know when I've looked at different applications for infrared that you have to start considering, okay, for my application, do I need 850? Should I go to 900 or 950 nanometers? Which IR LED wavelength should I be choosing for my application? How you've already kind of mentioned, probably the closer you are at 800, the more that red is going to be visible. What are the other things that an engineer needs to be taking into consideration when they're selecting which IR waveband to go with their LED?
So as I sort of inferred earlier, that at 850, you're probably about the camera is going to be about twice as sensitive as 940.
Right,
So
right.
let's say you're battery operated. So
Mhm.
the lower amount of energy that you need to power the LED, the more battery life you have. So
Right,
can you sacrifice little red glow for battery life? Is that an
right.
important feature? So it's things like that. I mean, certainly you can get 940 at the same brightness. However, it takes more energy.
Right, right. So the benefit then of going to the higher wavelengths is that you get it to where it's much more stealth, to your point, and much
Right.
less visible light. However, your camera has to be a higher performing camera, probably and also a lot
Not
more
necessarily
battery
high,
current.
not
Okay,
necessarily higher performing,
okay,
but more in that you know that there's going to be a drop off at
gotcha.
940.
Okay,
So it's just how do
okay.
you deal with it?
Right, right. Okay. And so that may require more power draw, and you've got to spend more time processing the image that you're getting back.
Correct.
Okay, okay, that makes sense. That makes sense. And then I think anytime we're talking about light, the other thing that's it's always important is the optic that we're going to be using with that
Sure.
LED. It seems like in general, I would think, well, shoot, especially if it's invisible light that's not going to be bothering anybody in theory. Why not just make the beam angle as wide as possible to make that vision, even easier and illuminate a larger area? What are the considerations we need to be taking into account with optics? Why not just go with the widest beam angle? Why narrow that beam?
So just like visible light, if you're think of the IR as being like a spotlight. If
Right,
you're not your camera is not able to pick up outside of a certain area, any light that's projected into that area is lost energy, as it were.
Right.
So that's just wasted opportunity. So if you're only focused on a very narrow field of view, then your illuminators should be, your LEDs should be the same field of illumination, maybe slightly wider. You know, if you're only looking at, let's say, plus or minus 30 degrees, your
Right.
camera, and you're illuminating 150 degrees, well, from outside of 30 degrees, all that light is going to be lost,
Yeah.
and there's no sense in using that.
Right. Right. So it just improves the overall efficiency of the system, and you can be much more
Exactly.
intentional about where you're trying to position your ability to see. So that certainly makes sense as well.
And we're also
Um,
seeing that there's a trend towards sort of rectangular or oval type of elliptical patterns so that we
okay.
get the 4:3 aspect ratio of the camera.
Okay. Are there specific applications that you're seeing are really driving that kind of decision to move to either rectangular or elliptical?
Well, I think that it's across the board because the
Okay.
sensors, the camera sensors are tend to be rectangular, and so
Right.
if it's rectangular, then having a rectangular LED also makes sense. What we
Gotcha.
do see
Okay.
is that a lot of applications they will sort of tile the LEDs so that they build a bigger area of illumination.
Right. Okay. And does AMS OSRAM have partners for different optical devices to help out engineers if they're designing with your LEDs, where they can get those optics for their application, or are they built in that you guys are selling along with the LED? How
So
does that kind of work?
yeah, so most of our products have built-in optics. So the
Right.
optics is attached to the device, and so we
Right.
have a variety of different devices with, you know, plus or minus, 30 degrees, 75 degrees, a
Okay.
variety of different field of illumination. We also have rectangular illuminated devices. We also have devices without optics, which allows you to go to a third party vendor. And we work with all the major
Right.
vendors so that you can get, the optimized solution for your application.
Right. So you guys really are covering the gamut from just ease of design, where the optic is already done
Right.
for you, all the way to full-on flexibility, so that you can get really creative with your optic design. That's just that's incredible. I think that's what every engineer wants to see, is that we've got that flexibility. That's good stuff. So, obviously, the AMS OSRAM, merger went on a few years ago, and it seems like just yesterday, but I think it's been a little bit of time now. And so with that, there's a great IR portfolio that you guys have brought to bear, that engineers should be considering for their infrared applications. And you've kind of touched on with the optics some of the value proposition that's there, that AMS OSRAM brings to the table. What are some of the other real differentiators that you feel like your company brings with your product offering for IR LEDs?
Well, so, we do have, a large portfolio of visible LEDs. So we have both.
Right.
We do all of the design, manufacturing in-house. So it's one-stop shop. It's not, buying, parts from different, vendors, etc. We also do VCSELs, which is the vertical cavity lasers. We also do edge emitting lasers, and we have them all within, the one group that I'm in, so that
Yeah.
we're sort of agnostic. What makes the
Yeah.
most sense for your particular application. We probably have a solution that will optimize for, what you're trying to achieve.
Right, right. Well, and I think that OSRAM history speaks for itself. I mean, there's an amazing amount of expertise in light generation that company has built over the years. So I think the combination of AMS and OSRAM together is a really powerful combination, that I know engineers should be taking a look at and making use of in their designs. So that's just incredible. So Thank you so much, Russell. This has been really, really fascinating. I think there's so many applications that really can benefit from IR LEDs in machine vision, and just kind of getting a basic touch on some of the things that engineers should be considering for these applications has absolutely been incredible. So I really appreciate you being here on the
Well,
current
thank you for having
and
me.
giving us some of your expertise.
No, I really appreciate that, and you've had a lot of really great questions, because you know it's not obvious how you use the IR in systems, and we do have support to help engineers achieve very innovative designs using this technology.
No question. The engineers that you guys have on staff are just a pleasure to work with. You guys have some true geniuses that really are tremendously helpful in the engineering designs that I know that we as a company have worked in partnership with. So I want to make sure that we're helping our audience to get access to those engineers. So again, Russell, thank you for being here. To our audience on the current, thank you so much for joining us again for another episode. If you are looking at a design with machine vision, if you are looking to integrate infrared LEDs and infrared technology into your designs, or any other lighting technology into your designs, this is an area where we feel like we've got a very, very strong expertise. We have our great partners at AMS OSRAM who also have a tremendous engineering expertise. We would love to help you with your designs and be a partner in getting you successful in that design as quickly as possible, making introductions to our own engineers and also the AMS OSRAM engineers. If you've got designs like that and you'd like to talk to someone who's an expert, please reach out to us at Shaping the Future, one word, Shaping the Future, at futureelectronics.com. And we would be more than happy to talk with you, talk about your designs, and start bringing some different solutions, ideas, and experts to the table with you to get you successful as quickly as possible. So again, thanks so much for joining us on The Current today. We'll look forward to seeing you in our next episode.